Hey guys, in this tutorial we're going to take another look at vases, and this definition is one that I used to create all of these vases in this render here, and we're going to take a look at how that was constructed. So you can see we've got this lovely little vase here, we've got control over shape, and we've got control over this little ridge over here as well that I've inserted. We've got control over the stem up here, and various other things such as this gap over here, and yeah, we'll see what else we have control of as we dive into it. So let's get started. We're going to get started with, as you may have noticed, a graph mapper. In fact, two graph mappers. And we're going to drop down our range component, and we're going to plug that into both of them. And I'm also going to plug in a slider for my for the amount of values I want. I'm going to set it from 0 to 16 for a nice binary number. And I'm going to change the graph type to Bezier, one of my favorites. Okay, and now we're going to get started with a cylindrical point. So I'm going to start by plugging in this into my elevation, and actually no, I'm going to start by plugging that range into a multiplication with a slider up to a value of 100 and plug that into my elevation. And let me just move these up here so that we're creating a nice tidy definition. Plug that in there, and we'll worry about these in a sec. Okay, so I sort of want this to be maybe up around here somewhere. In fact, 16 is probably way too much for the moment. I'm going to keep it at 8. And next, we're going to use this slider to control our radii values. So I'm going to throw down another multiplication here, another slider, and I'm going to throw that into my radius. And we're going to take this way down, and we're going to start toying it with it. So I want it to be kind of thick at the base, and then I want it to taper back in ever so slow, actually, maybe quite a bit. Maybe not that much, maybe something like that. Okay, and then with this one here, we might as well move these up a bit, and then make a copy of this, and move this up. And so this one is going to be our angle. So what I'm going to do is I'm going to create a range out of all of these, and actually I don't want to do that multiplication just yet. What I firstly want to do is I want to create a range between 0 and all of these values. And then if I plug this in here, it's not going to work straight off the bat. It's going to do something a little bit weird. So what I want to do is I want to flip that matrix around, and then when I change the angle here, there we go. So this curve is now shaping this region here. So what I'm going to do is I kind of want that to pop out in the middle, be a bit flatter on the rise, and we don't need anywhere near as many points. So this second range over here is probably only going to have a maximum of, even 8's too many, probably only like 3 or 4. Yeah, 4 will do. Well, 3 on the slider, 4 points. Okay, and actually before we do that, what we do need to do is remap these numbers. Let me just get rid of this as well, because this isn't what we need. We're going to remap all of these values and we're going to take the bounds of them, and we're going to remap them from, yes, from 0 to 1. And then what we're going to do is we're going to put down another slider, and this one, okay, so what we're going to be doing with this, if we just go back to our reference model, you can see we have several repeating elements. This is essentially one area here which is created as a polar array. So if I go back into here, what I want to do is I want a slider which controls my number of arrays. And so if I set this to 3, then I want another expression here. And this one is going to be 2 times pi over x, sorry. And this is going to give me my angle, which I'm multiplying this remap by, which I can then plug into the domain over here. And yes, okay, and so then the other issue with this is that it's remapping all of these numbers from 0 to 1, which means that this one right in here gets tucked right up against itself, which we do not want. And so the way that we sort of mitigate that is by constructing a domain for the remap, and all I'm going to do is change this bottom number. And so this is this controls my my inner angle. Okay, now let's tidy this up a little bit because it's already getting a bit messy. Drag these down here. Drag these over, and let's see, this can come down here along with these and this one here. Alright, so that's the first part of this definition. So now what we can do is we can create a mesh from points for that. Whoops. Mesh from points. And so our two sliders which control the resolution are this one and this one. And I'm probably going to get this wrong, but we'll see. So I'm going to do u plus 1. Change this to u, this to v, make a copy, and then get rid of our u and v, and change this to v plus 1. Okay, so I think this will be my u value, and I think this will be my v value. Let's find out when I drag them over here. I'm also going to need to flatten these points. Okay, nope, looks like I got it round the wrong way. So what we'll do is we'll swap these around. So that's we'll just make a copy of this, and we'll drag u into there, v into there, and then disconnect our first one from each. And there we go. I'm also going to turn my mesh edges on with Control M if you missed that. Control M while you've clicked inside the Grasshopper window previews your mesh edges. Okay, so there's the base mesh. Now the next part we're going to construct is that little notch that sits in here. That one and that. And so the way we're going to do that is what we're going to do is we're going to do a member index on this remap over here, and what we're looking for is the number 1, and we're going to convert that, we're going to cast that into a number. This way the member index knows exactly what we're looking for. We're looking for 1.0, and it's found it at index number 6. And so we're going to create a range with 6 is our number, and then we're going to, actually I think we can just plug that in there for now, so that'll give me 7 values ranging from 0 to 6, and then I can do a list item pulling out, let's see, I can pull out all of these values, and I also want to pull out these here, and maybe the elevation values as well. Okay. And so then we can, okay, before we continue with that, what we need to do is we need to create a straight line from here down to the bottom, because this is going to complete our our region that's going to be arrayed in the polar direction. Okay, so in order to retrieve that, what I need to do is I'm firstly just going to make a cylindrical point. Whoops. And we're gonna see how this is gonna work. My radius, I'm gonna start by taking from, let's see, what is my radius going to be? It will be, if I take another list item, and I take item 6 from this radius here. Actually, I could just do another list item here for -1. And I can do the same for here. So this is my angle, this is my radius, and these are my elevations. Sorry, just got a bit noisy there. So I've got, okay, so what are we looking at now? My angle is not quite right, because what it actually is 2 pi over x. Okay, so now I've got these points, which don't line up with the most outright point. Let's just see what's going on there. If I draw a line from 0, okay, so this is my most outright point. Okay, so what we're going to do is we're going to draw a line from, let's see, whoops, let me just take out, where is it? So this is my angle, my radius. Okay, so I've got these two sets of points. What I am going to do is I'm just going to modify this radius here. And the way I'm going to do that is with another graph mapper. So I'm going to, well, yes, okay, so this is why I wanted to do this. I'm just going to, instead of doing this range from 0 to 6, I'm going to do the range from 0 to 1 and then multiply the end result, because this way I can also use this range component for this graph here. And then we're going to do another multiplication of, let's see, Let me disconnect this value. I'm going to do, where is this radius coming from? It's coming from here and here, and this is going to be my new radius. And let's see. Okay, so yes, we want that final value to be touching, and we can do whatever we want with the values in the middle. Maybe something like that. I just want it to cut in a little bit. Okay, and then what I'm going to do is I'm going to create a line between these points and these points, and then I'm going to divide that curve up into, well, we don't need many for this, even 4 is probably too many. I'm happy with 3 points at 2 divisions, and what I'm going to do once again is another mesh from points. Oops. So this is my collection of points, which I need to flatten, and I need to do, once again, u plus 1, and let me just make a copy of the other ones that I've already got. So my u value is this number coming out of my index, and my v is hopefully this one. We'll see if I got that right. U and v, yes I did. Okay, cool. So that is now working. Okay, so now what we can do, we can start to turn off, actually we won't turn that off just yet. What we're going to do is we're going to do a Weaverbird join. And we're going to join this mesh, and actually instead of popping them straight into there, I'm going to plop them all into a merge node. So this is mesh 1, this is number 2, and we'll just flatten the inputs, and then preview these off. And so that is now a single mesh, and I'm going to mirror it through the, what is that? That is the XZ plane. And I'm also going to need to do a mesh flip on this. And then we can do another Weaverbird join on this side. And we'll see if I've done that right when we weld the vertices and bake it out. Yep, we're not getting any sort of weird edge along this, we know we're doing it right. However, it does look like we are having some sort of issue when it comes to how our what shall we say, our geometry is going to be arrayed. And this is because what I've done over here is 3 divisions, when in actuality we have 6 parts, because all we're doing is we're constructing 1/6 of the final geometry. So the way I'm going to resolve that is just by removing this 2 times. Okay, there we go. That's more what we're expecting. So now when we do a polar array of, I'm going to do it before we do this Weaverbird join, so I'm going to merge these 2 items together, and then I'm going to graft them, and we're going to do 3, yes, we're going to do 3 arrays. And then we can put that into our Weaverbird join once it's flattened. And just so you can see why I grafted it here, oh, actually maybe I didn't need to graft it. Let's have a look. 2 meshes. Okay, so it already grafts the structure. It already grafts the geometry inside the array, so we don't really need to worry about that. And when I bake this out, there is our mesh. Okay, it looks like we might have an issue. Let me just see what happens if I do. Okay, right. The issue is I forgot to redo the flatten. Okay, so now when we bake this out, all issues should be well, there should be no issues. When I do the Catmull-Clark subdivision, we'll see if I'm right or not. Okay, maybe I'm wrong. Because, yes, okay, so it looks like we'll also need to flip this mesh coming out of here. So I'm going to replace this item of the merge, and then redo the Catmull-Clark, and you can see we're getting no issues of smoothing around that border. If you're not aware of what was going on there, I'll just quickly run through that. It's quite a common issue. Basically what we're getting is we're getting a mismatch of normals. So because this part here is one mesh, and this part here is a separate mesh, if they're facing the wrong direction, Rhino, or in fact most modeling programs, they don't know how to interpolate the shading across that border. So what you end up getting is this black line, and that's a very clear indicator that part of your normals are facing the wrong direction. But as you can see, we solved that pretty quickly just by inserting a mesh flip. Okay, so now I can move this all back along, and what we're going to do next is the base part. Okay, so the base part is really easy to do. If we just take our cylindrical points, and we do a list item out, we're going to get these 4 points, and then we'll do the same with our other cylindrical point, which actually we didn't do a cylindrical point, we did a curve divide. And let's see, when I do a list item out here, it gives me these points. So instead what I'm going to do, rather than doing a list item, I'll just do a curve division of the first curve here. And that's going to give me those 3 points. And then I'm going to do a cull index. And I'm just going to cull the first point in the list. Because else we'll get double ups, because we've got those 4 points and then those 3 points, so we only take the last 2. So now we're going to flatten that and flatten that. Actually, no, I won't do it like that. I'll do it in my merge once again. So flatten those points, flatten those points, and then we also need the center point, which is just a construct point. And then what we're going to do is we're going to do a relative item, and this is just so that we can construct triangles between the base, what are we saying, the base point here and the center point. So we're going to do, let's see, relative item on all of these points here. So we graph them, whoops, graph them and simplify them, plug them in, and then our offset is just going to be inside parentheses, inside curly braces, sorry, 0 and then 1. I've done a tutorial on a relative item before, so be sure to check it out because it's pretty useful. Okay. So we plug that in there, and then we're just going to prune the tree on the outside of this relative item, which is going to get rid of any branches with less than 2 points. And then what we need to do is we need to do a what do we need to do? We've got our pruned points, so we need to do a tree statistics, and we need a list length. So this tells us how many branches there are, and so what we're going to do is we're going to repeat the center point however many times we need to, so that our data structures line up, so that when we merge them all together again, we merge these and these, and we should have 3 points per list once this is simplified. No, not quite. 0, 1, 2, 3, 4. Yes, after I do my prune. So we should now have 3 items per list, and then we can construct a mesh from these vertices, and we just need to specify that these are mesh triangles. So we'll throw that in there, and then we will add that in, let's see, over here. Oops, forgot this Weaverbird join. Okay, so this is mesh 3. Let's bake it out once more just to check that we're not getting any normal issues. And it looks like we are. So what do? We put down another mesh flip. Plug it in, bake out our Catmull Clark, and there we go. No normal issues. Alright. Now the next part we're going to do is the sort of the stem of the bottle. Of the vase, sorry. And so let's see, for this we need to retrieve these 2 items here. There's a couple of ways we could do that. We could grab a list item. No, actually we can't. We won't do that, because what we want is we want these parameters that created our cylindrical point. So what we're going to do is we're going to do a list item, and we're going to add in our -1 index. And so we want our, let's see, we want our, what is this? This is our radius value, and we're also probably going to want the angle. And so the angle is over here. Yes it is. So we've got those, and our elevation is just going to be this value here. So what we're going to do is we're going to do a range, and so this one is completely separate once again. This has however many values we want. 20 is far too many, I'll keep it at 12, which is still once again way too many. And we're going to multiply, actually what we're going to do is we're going to create an expression which is going to be x times y plus z. So it's going to be x times some number. So this is for our elevation. X times y plus z. If I create cylindrical points again, this is our elevation, and you can see it starts exactly where those points end. Probably want it to be a bit bigger. In fact, 50 may have been a bit small. Well, just because I got it right to the end. Okay, so we've got our elevation sussed. We also need to figure out the angle of these 2 points. And that's relatively easy to do. All we're doing is a range of this domain, and we use the same number of divisions. And then we're just going to grab a list item out for item index -1 and -2. And if I were to plug these, actually before I do that, my radius is this value here. And if I were to plug in -1, you'd see that would line up with those points there, and -2 would line up with those points there. And so we're going to construct these points separately. And what we're going to do is, let's see, our radius, for our radius, once again, we're going to use one more graph mapper. And once again, we'll set it to Bezier. And so for this one, we want it to start at 1. And we're going to multiply the result by this number here, which is our radius at this top level. I'm going to plug that into our radius value. And it doesn't look like it's changed yet. Now why is that? Ah, right, because I have to plug in the range into here. Okay, there we go. So there are my points. I've got control over those however I want. And we also need to create the exact same thing for the other points. But firstly, what I'm going to do is I'm going to do something for my angle. So let's see. I want to create a range between, let's see, 0 and this angle. Actually, the other way around. Construct domain between this angle and we'll see what happens. Between this angle and 0, and we want this many points. And so when I plug that in there, yeah, okay, so what I wanted to do was construct domain between here, and I'm just going to put a panel down for my 0 number. Plug that in there, and there we go. And then what I'm also going to do is I'm going to create a little expression, which is going to be if x is greater or smaller than. If x is, let's try if x is smaller than y times z, then we're going to give it 0, or else we're going to give it x. So if x is greater, let's see, my x value is this here, is greater than y times z, yeah, so this is going to allow me to control this, this little notch inside here. And this billows out way too much. So let me just stick that in a little bit. Oh, it's doing something a little bit weird in there. Okay, we'll address that later. Now I need to create my other cylindrical point, which doesn't need as much to it. It's just going to be, let's see, I'm going to start with a subtraction, and it's going to be this minus this, which is going to give me my domain, which is going to be from, what's that, 0.969 to 0.32. And then I'm going to plug that into my range as well. And then create another cylindrical point with these values here. And then I'm going to merge these points together. 1 and 2. Actually, let me do that the other way around. 1 and 2. And then mesh from points one final time. And so we know that we only have 2 points. Ooh, let's go with the U direction, hopefully. No, well, I really don't know at this stage. And once again, I'm going to make a copy of these. for U and V plus 1. And it's going to be this slider here. I don't know which one, so we'll plug in both. And let's try V. Yes, got it right. Okay. So I can get rid of that. Can move that down. And I can merge this into here. We should flatten all of these as well. Alright, and let's see how this now turns out. If I just preview all of this off and go back to my capital Clark subdivision. Okay, so you can see this slider over here now gives us control of where exactly this seam is, right along the notches there. We have control over the shaping of the top. Can do whatever we want with it. What else? What is this one? This is the height of this second part. We have control over the number of divisions of this neck over here. Same thing over here. And actually, one thing that I do want to address is my my elevation points for this bottom section. They're all quite uniform, which isn't necessarily a problem, apart from the fact that right around the bottom over here, we're getting a bit of lift off from our vase edge. So the way I'm going to address that is with a little expression, and that's going to be x to the power of 1 over y. And this is just going to allow me to sort of squish in these initial values. So this is my elevation here. If I just put down a slider, you can see that's enabling me to sort of flatten those points out just enough for it to be off, for just to be to my liking. Alright, and to complete this, we're going to put in a Weaverbird thicken, and I think I'm probably going to want to do it in the negative direction, just judging on the way that's turning out. So I'll set it to a value of 5, plug it in, and then plug that into my capital Clark, up my subdivisions to 3, and let's see what we've got. Okay, there we go. That's our vase tutorial. So let's just once again have a look at our creation parameters. We've got control over the shape of the stem. We can sort of create quite a flat one, or we can billow it inwards. We can, this is sort of controlling this this inner edge along here, and consequently where our where it's joining into itself. This is controlling the spread, how much this bottom part is opening out. We've got control. Oh, okay. So that one has broken down for some reason. Let's see if we can quickly address that. Let's see, my mesh from points. What happens when I increase this? Breaks down for some reason. Insufficient number of points. So I have 9 points. Let's see, 5 and 9. Oh, it looks like I might have plugged in the wrong slider into there. There we go. Okay. That was an odd issue. No, actually, it wasn't really that weird. It's just I had the same number, or the same parameter plugged, or the same value for these two sliders. You can see how easy it is to make mistakes like that. But now if we change this, we should be able to create an indefinite amount of subdivisions to the, not subdivisions, sections to this, and then we can bake it out, and there we go. Looks fantastic. So that's another rendition of how to create a parametric vase. Hope you enjoyed it.